I'm Tommy Brooks, business development for Aroma Bit. This is Jim. He's also helps out for business development in the U.S. and Goto is from Japan, actually. So it's a Japanese startup technology company. We've been around for about 4 years now, I think. My friend is the founder. So we build these chips. These are smell sensors, so they can digitize smell. And how it works, in essence, we recognize any type of smell as a pattern. And what the technology is using, I don't know if I have the. So what it looks like is something like that. It's using a technology called QCM, so it's called quartz crystal microbalance. And what it does, it can detect the change in mass of odor molecules. And on top of these sensor elements, so there's 5 right here, but on top of each sensor element is a thin membrane coating on top of it, and each has a different chemical affinity. Each kind of special membrane interacts with certain type of odor molecules or a set of odor molecules. So we have 5 here, but we actually have 35 as a product. And but if you what we're trying to do is mimic the human nose receptor. So if you think about the human nose, it has about 400 nose receptors. So right now we have, let's say, 35. So we're not quite at that level where the human nose is, but we're developing about 50 right now, and possibly 100. Again, the concept is recognizing smell as a pattern. So we'll show you a quick fun video first.
Breath freshening gum, Aquo, developed for one reason. Japanese people have bad breath. So said 70% of foreigners surveyed in Japan. Hugging and kissing may be typical greetings in other countries, but in Japan, where it's far less common, oral hygiene just isn't a priority. To make matters worse, if someone fails to notice that their own breath stinks, the Japanese are too reserved to point it out. We needed a solution. Introducing Mr. Sniff. This little guy is a high-tech breath connoisseur, a breath-analyzing robot equipped with a state-of-the-art smell sensor. We developed 7 components that allow him to tell one smell from another. The moment someone's breath enters his nose, he begins analyzing its quality. Every result is presented as one of 10 different gestures. Each gesture was designed to be comically exaggerated so that people would not be put off by the results. We also took Mr. Sniff on the road, where he analyzed the breaths of 6,800 volunteers. 67% of the volunteers were found to have bad breath. This was a major wake-up call. Mr. Sniff was a huge hit. Pointing out bad breath had transformed from a social taboo into an exciting new trend. Over 12.4 million people ended up learning about the campaign. Gum sales were down, but Aquo sales rose by 3%. People were now more aware of their breath quality than ever. A national dialogue about oral hygiene had begun, all thanks to a little robot who was able to analyze people's breath without hurting anyone's feelings.
Excellent. Only in Japan, but right. So that robot has our smell sensors equipped with it. This was a collaboration with like Dentsu, one of the advertising. Oh yeah, I think it's okay, but advertising company agency, and we actually won an award for this commercial. So let's go ahead and let's do the demo.
Basically, I think the chip is sort of passing around somewhere. What we've got, as he said, is quartz crystal microbalance technology, which is just a fancy name for a quartz-based scale. And we have a set of 35, so far 35, looking at 50 to 100, but right now unique patented polymer coatings that we apply to each microbalance. That each coating has an affinity to a certain category of molecule. One will be the hydroxy, essentially the water-based chemical. One's very sensitive to any of the H2O components. Others are ketones, alcohols. We've got kind of the secret sauce of how we've divvied these categories up across the sensors. And it's what we do as air travels through the sensor array, which we got here is an array of these things. We've got 7 chips. Each one has 5 sensors on it. There's a total of 35. You see there's 8, but one of them is actually a temperature and humidity sensor because there is sensitivity. And if I look at what's inside this box, what we've got a sample chamber, we've got a particulate filter, and right up above the particulate filter, we've got one of these that's wired into it. And, whoops, I screwed it up. Okay, where do we go? I'm working from the wrong side. I'll let Tommy do it. What happens as molecules are adsorbed onto that polymer, it increases the mass. Now, that's obviously not increasing it very much, but these things are quite sensitive. So as the mass increases, the crystal frequency will drop, typically drop. And what we do is we sense the frequency differences and looking at doing a little signal processing, a little mathematical magic, which is really not very complicated. What we do is essentially assign a pattern. So we can put a sample into this. Good job. Okay. We let it stabilize for a little bit. Here we go. And you see what it's doing now. As you see each of these lines representing those 35, it's picking up. Each one is absorbing mass, perturbing the frequency. We're looking at those frequency shifts, and we consider that to be a measurement. We look at what's the peak, and we look at a few other parameters of that waveform, and then we develop one vector, a 35-element vector, that we put into the database. Actually, we generate a measurement in this application, this system here, we're running about, I think, 100 millisecond per sample. And we just sample continuously for the period of 5, 10 seconds, 20, 30 seconds. I'm bad. I wanted to see what happened. I sampled for an hour and a half the other day. Works fine. And basically from that CSV file is into the database, and that represents that measurement. Then we get a set of measurements, and we can essentially say, if we put another unknown substance in there, we can go against the database and decide what it is. That typically is not the kind of thing we're asked to do. Most of the people we've been talking to so far, I'd say we've talked to over 500 companies. We've actually done demonstrations at a couple of dozen. 2 weeks ago, we were up at I was up with one of the gentlemen from Japan. We were up at a biological testing laboratory in Madison, Wisconsin, and we were putting kind of unpleasant bacteria in here and looking at them. And when we actually plotted up, we've done a pretty good job of categorizing. They separated well. Each bacteria had its own unique signature. We were able to look at the glass plates themselves, at the growth media, and we could assess that they were providing less than 5 to 10, maybe 15% distortion of the measurement, so they were insignificant. A couple of days after that, we were in a company that makes carpet cleaning and carpet cleaners, the chemicals, and we were checking carpet that had been soaked in cat urine, skunk, garlic, smoke, mildew, and then we looked at the virgin carpet that had never been cleaned, the clean carpet, the carpet that was contaminated. Then we looked at the carpet after cleaning, and again we were able all the skunk measurements clustered well, all the garlic measurements clustered well. So we were able to, at that point, assess which carpet, the state of the carpet. Was it clean? Was it dirty? And the reason that's important is before they can advertise it, they give you a cleaner smell than brand X. They have to have a jury of people check to clean the carpet and to say, yes, it does smell fresh. It smells minty. It's clean, And in some cases, they have 200 or 300 people. And they actually pay their employees to come in and spend an afternoon doing this, and they give them like a lunch or something, and they're losing several thousand man-hours a year just doing that. And what they're looking for is, can we get a consistent quantitative measurement of what is a clean carpet? so that we can then avoid, all the manpower. And it goes on. We've talked to automotive companies that are interested in putting this kind of things into the headliners of the cars to detect impairment, alcohol or whatever. Or as car sharing gets more and more popular, the car companies are now seeing that what we're going to do is there's no way to check the quality of the car when it goes back. So they don't know, is the car dirty? Did somebody put a wet dog in the back? Was somebody smoking in the car? Did somebody leave peanuts in the back seat? So they become interested in things like being able to take that kind of data about the interior of the car itself and utilize that to determine whether the car is capable of going out on rental again or whether it needs to be scheduled for service and cleaning. So those are a couple of the applications of people we've talked to. A wine distributor who generates codes from this and prints the codes on the bottle and has an application for the iPhone that lets you match up similar wines based on their aroma. We've done studies of wine as it's corked, uncorked. 20 minutes later, an hour later, 2 hours later, we can see the difference. We've looked at milk, milk on the counter, 3-day-old milk, 2-day-old milk, refrigerated milk 2 or 3 days old, and we can clearly see the effects of the aging. So we were displaying at the Institute of Food Technology show down in New Orleans a few weeks ago, and we have a lot of people that are very interested now in being able to do things like look at, some of these things are stored for 6 months. After the storage, how is there any quantitative metric that lets them get a handle on how much deterioration, if any, in the quality? We've been talking to people about online marketing of fragrances. We've talked to fragrance companies. We have a couple of these at a couple of, people that do fragrance and beer and wine are kind of interested. So that's basically what it does. It's fundamentally simple. This eNose kind of concept has been around for, I'd say, at least 50 years. Everybody does it in a similar way. There's a consortium in Japan now that what they're doing is using a CMOS camera sensor, and they're overlaying coating on certain areas that fluoresces as you get chemical uptake, and then by them essentially looking at a map and then patternizing it that way. There are other people that are using kind of laboratory dropper modules and looking at the patterns. I think the thing we have going for us is that we've seen these chips actually in our lab running for about 3 years. So they're not consumables. The laboratory systems typically are $12 or $15 for a single measurement. And we'd like to look at things like bacteria. We've looked at bacteria. We'd like to start looking at some medical applications. Unfortunately, we need about half the staff of Microsoft to be able to get through the regulatory morass to actually get into that market. So it may take us a year or two. I think we're, 18 people currently? That's something like that. So another year or two. But that's what we do. And the demo, let me do this one too. This is actually something that's pretty horrible. I don't know. My wife is into kind of alternative stuff. It's a nice stomach medication. It's awful stuff. But actually, I kind of like it. It works. So I put that in there. We open up there. And again, we get a different kind of a fingerprint. I mean, actually, speaking of fingerprint, this is interesting. Oh, dear. Ha, ha, ha. Well, that's not part of the show. I don't mind it, but it smells kind of bad, but it does a great job if you got an upset stomach when you're on the road all the time.
Oh,
huh?
Yeah, you know it. You know it.
Yeah, my wife takes it.
That's it? Oh, Serogan.
But this is good for the diarrhea or...
It's good for anything. So what I was going to show you, can we do this? We're going to open it up and stabilize. And I put my hand in there. So what you can see from that is that you can sense everybody will have a different characteristic. So we've actually been talking with some of the fragrance companies about things like being able to compound fragrances at point of sale and base them on the modify them according to how people actually have their own basic odor, and so that no matter who you are, when you buy it, it smells the same. But this is, it's pretty quick. There we go. I'm sorry?
Oh yeah, right there.
Huh?
There's a fan right behind you.
Ah. Little details. Anyhow, I think that's about it. Let's go to Son. You want to talk a little bit about the company? Yeah. This is the fun part. I'm sorry?
So there's an extra little help mic if he's just going to talk on there. Otherwise, you can grab the handheld.
Oh, okay.
Oh, that's a microphone?
Yeah. Just don't go to the restroom.
I just want
It is, because you forget you've got these things on, and you start walking around in a big trade,
Oh,
trade
yes,
show
yes,
environment. You walk around the room and you say things you think you want to hear.
Hello, everybody. I just got here, so I'm still having a jet lag. Excuse me. It's a morning tomorrow. It's a 5:30 in Tokyo now. So excuse me. So actually, our corporation, just as Jim explained, that we established in 2014. It's running about, this is the 6th year. Then about employees like 18 people. Very, very small startup. But startups, like you said here, is very popular. But in Japan, it's so much. Okay, so this is, we are the braver, right? So anyway, then one is Kuroki, that's the CEO. He has a background of the finance field. And also the CTO Hashizume, his background is he used to work at the Nokia. That's some of them, the Nokia, that's a phone company, right, in Finland. So we have 3 locations. The headquarters is Ginza in Tokyo. Some of them, that's a right center spot of Tokyo. Fun lifestyle at night. Anyway, then also, my office is here, the Aoyama. That's also very, very nice area in Tokyo. And then this is sales and also administration. Then most important, the development. That's in the Kawasaki. It's about half an hour by train from Tokyo. Then they have about 9 people here, the development. And also that's a lab and also development stuff in here. Then, excuse me, just I want to skip a little bit. Okay, actually our functions very similar, simulate the human functions as well, human nose function. Human nose actually has about more than 400 receptors. Like Jim explained, that chipset is as the human nose receptors, right? So then that goes to the human brain, and then that's having a signal, and then there is the database, which you had it before the smell, right? Experiments, such as the smell of the apple or bananas or that. That's what converts to that there. So that's a basic function, and also this is the symbol of the odor patterns based on the 35 membranes. Okay, this is number 1, number 2, number 3, and towards the 35. That's 3 degrees. One is the small, medium, and large. The combination of that's patternized all those smell. For example, this is green pepper, tomatoes, different patterns comes out. All right? This is herb. All these are different patterns. Okay, as you see that, the nuts, even coconuts, hazelnuts, different patterns. That's what we see, visualization of smell. Have you seen this before? I don't think so. We are the first one in the world, right? So this is very, excuse me.
Is that a spatial mapping of the chip?
Yeah.
Each star is representing one of those lines after we've done a little bit of signal processing. So it's
Right. So this is first, second, third, fourth, fifth, right? That's membranes. Then that makes the strength of fragrance. Then this one's like a impression of smell. That's a fruity, sweeties, something like that. And also this is like alcohol and fermented odor. That's character of the membranes. Yeah. So also we can do the simulated the test. Because this is a, can you see? Yeah. This is an example of the wine, white wine. Then we do have a database about, based on the wine, that we have 88 original smells database. Actually, we do have about 1,000 database, but for specializing the wines, yes, that we have all those original fragrance. Then it's showing the this wine very the high similarity, the lime, and the second comes out the lemon and so forth, right? So that also comes out that. This is a very interesting example. We tried Coca-Cola, Pepsi, original. You try it. Coca-Cola and Pepsi, if you smells it different. But if you smell the diet, very, very similar. Also, looking at that, Pepsi hasn't changed the smell that much between original and also diet. Coca-Cola is a difference between original and diet. You try that. I did, but yes, it is. But we can see the smell, right? So that's what it is.
It's not coincidental.
Right. Okay, I said that's this is the one of the example of the wine. There is the Aroma Star. That is the sommelier's training kit. Contains the 88 kind of the all those original smell, such as grapefruit and the mint and all those, rose and peppers and those. This is one of our example of the database. So all these, it looks very similar, but all individually, all these are all different. So that's what we can do, to patternize the smell, ingredients, okay? That's about it, so. Any questions? Very unique, right? Isn't it?
Hi, I have a question. So I saw in one slide that the top few circles represent the strength of the smell. So does that mean you don't normalize this for the strength of the smells? Like for your demo, when you put in something with the smell, how do you normalize for how much you put? Yeah, something.
In this case, no. We have done it for other studies, but not for this particular case.
Okay.
This is not the analyzer of ingredients or original substance. Can you excuse me?
It's a fingerprint of the thing.
Right. Fingerprint. It's like a QR code of the smell.
We don't try to deconvolve it into its components.
Okay.
We're just looking at, say, if you put in an apple pie that was baked at 10 in the morning today, you'll get, that's the apple pie. You'll get a picture of what that is. So you get an overall picture. Now, in fact, we can actually do some degree of modeling with the components, but that's not really our focus right now. Right now, we're just trying to identify. And again, what we're seeing people doing is things like, and this is a real example. We were asked by a company to have they do very large circuit breakers, as in refrigerator size, because they're using thousands of amps. And they would like to detect the wires warming up before they have a failure. Because when the breaker trips, it takes an automobile factory down for hours until they come back and repair everything. So they would like to get even a few seconds, a minute or two of advance warning. So we did a simulation where we actually put wires, we wrapped the wire coil inside there, and as we increased the amperage, we could actually see the wire heating up. Because we're starting to get outgassing of the different components, the solder, I think primarily the coatings, the plasticizers, the epoxies that are not reacted in the coating and things like that. And we start to see that fingerprint changing over time as the wire warms up. So yes, I think we're looking seriously at that kind of an application. We've got several companies actually asking us to look at that particular application. Gas leakage, coolant leakage, even coolant leakage in a server rack. You're starting to get more and more higher performance applications that are driving the CPU very hard. So yeah, we're getting to where I think water cooling, liquid cooling is going to become. It's getting pervasive, and for example, in the AI, the training space, where they're actually crunching a lot of data, and some of the makers are starting to concern about, as we go to fluid, can you detect pinhole leakage? So we've been asked to say, can we detect any of the components in the coolant? And some surprise, the automobile companies want to know the same thing. So.
I have two questions actually. So I missed the beginning, your presentation, I suppose. So question one is, and you might have covered it, how do you calibrate like this sensor box? And like if there are other objects around which also have strong smells, like how do you take that into account? Like that is not mixing in with the object that you are trying to smell, or the smell of the room, or whatnot. That's question one.
We did a POC with an online marketing company. And that was one of their concerns too. And in fact, at this point, with the way that box is developed, we do actually see some issues because it's not what I would call optimally well sealed. It's a very early version of the product. And we do see, I could probably tell you which conference room you were working in. We do see influence. On the other hand, what we do is we sort of self-calibrate, because whatever the environment is, once it's stabilized, we'll look at the delta to the environment based on what you put into it. But to some extent, we are seeing that as still one of the problems we have to work on.
Question two will be like, there are other companies which are selling individual sensors of multiple kinds for detecting various different things. So the value add here is you basically made it into a camera-like sensor where you've integrated multiple different types of sensors into one system, and then now somebody can leverage that. Is that the value add?
Yeah. Yeah. I mean, one example. We actually talked with some of the in-home smart home folks. Smoke sensors. Now, the problem is that the smoke sensors are actually typically working on a particulate. They're not going to tell you it's smoke until you've got fire. I mean, in our case, what we would prefer to do is say, we can tell you that there's something going on in the wall before it breaks out. So, where I would like to see us go with this is to actually put enough intelligence on chip to be able to customize the chip. We can customize it. If you know what it is you want to monitor, for example, what categories you want to monitor, we can generate a subset of the 35 and customize one chip. And I think if we're clever, we could get a recognition algorithm that's also parameterized to what you want to see onto that chip. So we would hopefully have one hardware, one subsetable hardware implementation, and essentially a parameterization would allow us to use basically the same hardware to go after a lot of different things.
So essentially, you're trying to add AI plus the camera, like the sensor.
We're not there yet.
Okay. Yeah. Okay.
But I am actually going to take that whole spreadsheet that we get, several hundred.
So it seems you're able to categorize a lot many different types of smells, which is great. Are you able to reproduce the smells? Are you able to reproduce the smells?
We've talked to a couple of companies about that. We've got one car company asked us if we could work with a company to do that, to keep the new car smell permanent. I'm not sure I like the new car smell that much, but no, we don't. We're not going there. On the other hand, we could work with somebody who does that.
It almost seems like, cartridge of a printer, that you have a different colors of the printer cartridges that you have to fill up. And if you're able to put that molecule in the air for 2 or 3 hours, then you get a very different smell. And if you're able to put that molecule in the air for 2 or 3 hours, then you get a very different smell. And if you're able to put that molecule in the air for 2 or 3 hours, then you get a very different smell. And if you're able to put that molecule in the air for 2 or 3 hours, then you get a very different smell. And if you're able to put that molecule in the air for 2 or 3 hours, then you get a very different smell. And if you're able to put that molecule in the air for 2 or 3 hours, then you get a very different smell. And if you're able to put that molecule in the air for 2 or 3 hours, then you get a very different smell. And if you're able to put that molecule in the air for 2 or 3 hours, then you get a very different smell. And if you're able to put that molecule in the air for 2 or 3 hours, then you get a very different smell. And if you're able to put that molecule in the air for 2 or 3 hours, then you get a very differ and mix it up with the other molecules, like for example, the picture we had previous to this showed that molecule 0 has stronger smell versus molecule 1 has a lower smell, and you mix it up, all those 35 smells that you gathered, you should be able to reproduce it. And all you need is just those 35 different types of air particles to fill up the air.
The first time I saw that done was about, I'm going to say about 12, 15 years ago at SIGGRAPH. There was a company that was actually doing that. They were displaying things on the screen, and as you saw the display, you smelled it. They had roses. They had, I don't think they had a dead fish, but they had, various things, and they would, as the picture showed, they would generate the smell. But in order for it to work, you had to be positioned relative to the jets. They had two small jets that were separated about this far. There are other companies. Is Panasonic doing that? Or Sony? Yeah, Panasonic, I think, is, yeah. Panasonic is actually doing something like that, I think, right now. You do have a little bit of a problem in that your consumables run out. So if we were looking at doing it in the car environment, you'd have to go back and have these things filled occasionally, just like your inkjet printer. But yes, I think it would be interesting working with them. But we're on the recognizing side. After we recognize it, quantify it, and digitize it, quantify it, we could actually feed that into somebody else's algorithm if they wanted to try to generate it, and we could actually monitor it and see if they were getting the same result. That's not this year. That might be a week or two away.
This is one of the example, right? This is case of wine. Thank you. Okay, this is nice Chardonnay, South African wine. Okay, immediate open, this pattern comes out after 1.5 hours, changing the patterns, right? Then after 6 hours, completely changed from immediate opening. That's also one of the example.
So how expensive is it, and where can you get it?
You want to talk to me?
Whoever has the answer.
Well, maybe. Huh?
Yeah, for hackathon or for like just hackers in general.
It's expensive now.
Low quantity.
Yeah, but actually, yeah, we want to be de facto standardized with this chipset, which will be billions of manufacturing, maybe about $1, $2. That's what we are trying to be in the future.
Sure.
Near future. Yeah, so that's why, like Jim said, we have been talking to everybody because smell is all over, right? So we've been talking to automotive companies, and actually our major company dealing with in Japan, that's food and also beverage and also cosmetic, right? So then we want to be de facto standardized. Then maybe $1, $2, or I don't know, $10, or that's we are trying to. But currently, yes, that's we have to return of investment phase. So.
It's a little more than $10.
So too early for hackers.
About 500 times. You want me to jump?
Yes, please.
Actually, if you know what you're trying to build or you have an idea, then you can pitch it to me and I'll pitch it to the CEO, and we might be able to give you or rent you a chip. I've already talked to him about this, so yeah. So
So
I'll give you my business card. Yep.
Please.
yeah, so I joined this talk a little bit late. I'm not sure if this was discussed earlier. Do you plan to prepare like any sort of data set and make it public? Because I see like you have like 35 sensors, so you can essentially get like a 35-dimensional feature vector for each of the smells corresponding to different time steps and different conditions. Do you plan to prepare a data set or something? Do you plan to prepare like any sort of data set of different type of smells that can be shared with other people, like with public or community, research communities in general?
I think we could. I think so. Yeah. I'm not sure if we thought that far. Whoa. I'm not sure we really thought that far ahead on that one. But yeah, We can talk about it. You got a minute afterwards, we'll talk about it.
Okay, sure.
Thank you.
Because I think like if it's shared, then we can like use different type of classification. And I think there was another question about generation, so people can try different type of generative algorithms and prepare new kind of smells and other things.
Yeah.
Yeah, this is very similar to all of the hardware that we work on, like camera, computer vision, and all these things become platforms. And we're making them open source, making them libraries that people can share data sets. So it's very similar analogy if we could have this. Yeah, I was wondering how you source data. Can you do crowdsourcing?
It's not quite as easy as getting your picture on YouTube. I mean, nobody, it's easy. Everybody's got a camera, It makes it easy to source the data. We're not there with, everybody doesn't have one of these in their kitchen yet. I would like to put them in toasters. So when your toast is done, actually we have a coffee maker manufacturer in Germany that actually was looking at putting them in there to know when the coffee was done. But that's more of an issue for us. Right now, what we're trying to do is, as we work with different partners in different industries, we're doing things like, for example, making very good deals on use of the equipment on the condition that we share the data. As I told you, we're working with a carpet cleaning supplies maker. If they would measure 500 or 600, we probably would share that. We're talking with a couple other companies. Typically, they're willing at this point to share the data with us. And then, as we go into real production, we'd like to start building a significant database out of it. Obviously, we'd like to monetize the database if we can, but
so
I'm not sure yet whether I could sell advertising at the front of each one, though. I could advertise deodorant.
Actually, it's a follow-up. So you did mention about talking to a perfume company or two. So I was curious about the use cases that you have discussed with them, and then what is the output of those?
One of the things we have discussed is the ability to essentially, obviously quality control is one, manufacturing, the process, but the other is, how would I put it? Fragrance marketing online. That's one application where I can't say too much because we are working with a company on that. But the idea would be if you know what fragrances you like and you tell me, and I have them in my database, I can tell you which of my proprietary fragrances would match up with them. So things like that. Or as one company said, they want to do point of sale compounding. And they're actually doing it with cosmetics now. But they said they would like to get into actual final compounding of the fragrances at point of sale. But there are things like online. That's one of the reasons I think the guy in Japan is putting who's putting those codes on the bottle, because you can use his iPhone app and you can recommend similar wines, so you feel a little more confidence in ordering them online. And the fragrance people are looking at the same idea.
Thank you. Each bottle has a aroma code. That's why we call it aroma code. So per your question, also one thing, the cosmetic company, we participating the one of the biggest cosmetic exhibition last year at the Paris, the Louvre Museum. We were invited. Then all over from the world, especially Paris and also Italian cosmetic makers visited. They are using our technology when they build a new development of the product, fragrance. Recently, they have to go through like a gas chromatography to get each the ingredients, right? Took about 3 to 1 month or couple, maybe half a year. But now, like Jim showed it to you, we can make it as a patternized smell second. So they can create a shorten the lead time of the development of the new products, such as the cosmetic and also food and beverage as well. One of the chocolate makers in Japan, they're utilizing our machine, right? Each cacaos, chocolate and cacaos has a different patternize it. Then shorten development cycles to make a new chocolate. Yep. So this is revolution, very revolutionary thing.
Yeah,
So
you're feeling the gap. There's a gap, the senses gap. We have vision, we have audio, we have touch, we have sensors, and we can reproduce those things. But smell was a missing gap.
exactly. Human has a 5 sense, right? Only the smell is way behind. Other than that, they're all talking about, they're looking at the 22nd centuries, but only smell is still 20th centuries.
Yeah.
That's why we are looking at it, digitalization.
Part of the problem we have is that there's no, so far, I think, and I don't think the research has caught up to it. When you talk about visual and audio, we can look at these things based on the concept of frequency. This is very helpful in understanding how to analyze. But we have yet to define a spectrum of smell. I mean, the research guys are letting us down. They have not come up with, a mathematical system that lets us do the kind of modeling and transforms and things that you could do on optical and audio data. And I think that's been really the reason that those have been able to progress as well as they have, because we've had an organizing mathematical structure that is a good representation. And so far, I don't see a mathematical representation of taste and smell. Feeling, I'm not sure about. I don't think so. Haptics, I'm not quite sure either. But getting there, I hope.
Pressure sensors, stretch sensors, yeah. Any more questions? I think, can people go closer to take a look at the machine?
One thing I want to show. This is, he showed it to Mr. Sniff, right? Okay? All our sensor on the back on his head. That is a sensor of the smell. That's a core part I got to tell you. Okay, they have been looking for all over the world to sense the smell. Then they hit us. We are the only one could make this robot. Yeah, last year, actually.
You should make a dog version too.
Oh, yeah, that's good.
Advertising agency would let us. I would carry one everywhere.
Definitely, yeah. Yes, thank you.